Hello, Anna here. We're now going to start Unit 14. And first of all, what we're going to go over is the gross anatomy of the female reproductive tract. All right, obligatory slide on the descriptions and definitions and such of your genitalia. Okay. Make sure you go over these and transfer this information to the tables in your lab manual and that you know them. All right, so I skipped over the other slides that have just the words on them, but that doesn't mean they're not important, so make sure you know them. So what I want to do is go over the picture. So right now what we've got is a mid-sagittal section through the female pelvis, okay? What you're going to notice is right here, you've got the sacrum, okay, coming down. You can see the ligaments here. All right, up here is your pubis. Right behind the pubis is the urinary bladder, and right behind or posterior to the bladder is the uterus. So one thing I want you to always visualize is the uterus kicking the bladder. That way you don't get them backwards. So the bladder is a soccer ball and the uterus is a kid kicking the soccer ball. Do something to keep it straight, okay? Now, with this pubis right here, so let's kind of go down to the bottom, okay? You can see the pubic hair here, and then the outer fold, which is the labia majora, labium majus, all right? Singular is labium majus. I honestly don't care which one you use, just remember it, okay? And then the inner fold is the labia minora, okay? These are going to be homologous to structures that differentiate into the male external genitalia. So basically the scrotum for the labia majora and the the ventral penis for the labia majora. So go back and look at those homologous structures. So what I want you to visualize is an embryo that basically looks female, okay? And then if the SRY gene kicks in and it releases a huge bath of testosterone, that begins to differentiate these structures into the male structures. And the structure up here, you basically have two sets in the embryo, and the testosterone causes the female portion to atrophy, okay? And then the male portion becomes more developed, okay? So continuing with homologous structures, so right there is your clitoris. This would be homologous to the dorsal penis, okay? You can see here the opening to the vagina, and you can see where the urogenital diaphragm is here and here. Excuse me, that's not the vagina. Oh my God. The urethra. You can see the opening of the urethra going through the urogenital diaphragm more anteriorly. Now in the male, you would have had the prostate gland right here. In the female, you don't have that. Posterior, so here's the urethra again. Posterior to the urethra is the vagina, also going through that urogenital diaphragm. Now just behind or just posterior to the vagina are two little glands on either side of the posterolateral vagina, and these are the vestibular glands, and they are going to secrete a lubricant that goes all along this surface right here. There are other glands that secrete into the vagina for lubrication. Okay, so this is the vagina going all up here. Lots of little glands secrete a lubricant. But then also right here is your cervix, okay? And then this is the aperture or cervical opening. And that also will secrete a mucus that comes out. All right, the mucus there is really only thin and runny when you're fertile, otherwise it's more of a plug. Okay, so this structure is the cervix, and the rest of this is the uterus, which you can divide into the fundus and the body and so forth, but I don't care if you remember that. All right, and then, oh, I forgot to point out the rectum. So you've got the rectum there, bladder there, and then uterus right there, okay? Now, in this particular view, so you've got your pelvic cavity, okay? Coming off the uterus, going anteriorly, is the round ligament, which anchors that uterus anteriorly, okay? We're not really seeing the other ligaments very well. Why is my suspensory ligaments? labeled there because you don't even see the suspensory ligament. So we're just going to ignore that. I guess, I don't know why it's not deleted. All right, now this thing right here is the ovary. The ovary does not open to the uterus at all. It's a completely separate structure. There is a piece of ligament here that we call the ovarian ligament, and it's just a little bit of fibrous connective tissue that anchors the ovary next to the uterus, okay? Now the tube coming off the uterus that is open is your fallopian tube right here, okay? And then this ends, and it's got all these little fingers at the end that translates to the word fimbriae. Now the fimbriae of the fallopian tube do not touch the ovary. They are right next to it, but there is a gap. The fimbriae wave, plus the lining of the fallopian tube is pseudostratified ciliated columnar epithelium. So it's got cilia. The waving of the cilia and the fimbriae create a current that will suck an egg that has fallen out of the ovary up into it. Okay? I think that's everything on this slide. Let's move. All right, here we are looking at the perineum, not to be confused with peroneal or peritoneal. Perineum is going to be the outside region there between the legs, the urethra, and the rectum, okay? It's technically two triangles that we will actually, let me fix my triangle. It's not very good. And if you end up going into an obstetric area, you will learn more about that, okay? So you got two triangles right here. And now I'm just going to erase them again. When we use those when we're discussing female anatomy and healthcare and so forth. So right here, you can see the mons pubis with all the hair all over it. All right, now you can see they've ripped the hair off here, so she's got a Brazilian, a modified Brazilian. So you can see the labia majora here, and then you can see the labia minora here, okay? And then you've got the clitoris with its clitoral hood, which is also called the prepuce, okay? Get rid of some of this so we can see more clearly. All right, now right there you see the opening of the urethra. Now what I want you to visualize is if this was a male baby, a male embryo, and it was going to differentiate into male anatomy, this stuff here and here would come together in the midline and encase the urethra right here. So this would swell and this would swell, and it would seam together in the midline, and the urethra would go down the middle of it, and then you would have a giant penis or a giant clitoris. That's now called a penis. Anyway, and then the labia majora right here and here would actually come together in the midline and fuse to form a seam, and that would be your scrotum. Okay? Now also here you've got the opening for the vagina. If you are young enough, you will see a hymen. This becomes flexible at puberty, so it actually retracts a little bit. It's easiest to see a hymen in an infant, but that's kind of gross, so we're not going to look at that. And then you can't really see it on this picture, but basically right here, oh, that's not a good color. Let's see. Basically right here and right here are where the greater vestibular glands would be located. Okay. All right, let me zoom that out, and we'll go on to the next slide. All right, so in this picture, we've taken all of the gooey outer stuff out of the peritoneum, the perineum, so that you can see the structures a little bit better. So you can see how the pubis bone is here and here, and then you got the pubic symphysis, which is going to be the cartilaginous area where you're tying the two things together. You can see better the glands of your penis, and then the anchoring tissue right here. Now, all of this and all of this is all erectile tissue, like in the male, which is why it looks so similar around there. So during sexual arousal, the clitoris swells, this structure swells, and then this also swells here and here to kind of hold things together, I guess. All right, now the gland, you've got the vestibular gland right here, the greater vestibular glands, and they've got those little ducts that are going to come out to the surface of the perineum on either side of the vagina. All right, and you can see the opening to the vagina there. And I think that's it for this picture, so let's go on. All right, so let's look at the uterus. Now, first of all, this is a picture from the posterior. So you've taken this out of the pelvic cavity and you're looking at it from the back or the posterior. And I know this because of the way they have shown the round ligament. So here is where it would be on the uterus, and then it's going to go forward here and here to anchor on the anterior pelvic wall. Okay. Now, in this particular view, you are also seeing a very nice sheet here that is very broad, and so it is called the broad ligament. So the round ligament anchors anteriorly. The broad ligament anchors the uterus laterally, okay? Then we have two other ligaments. We have the ovarian ligament, which is going to anchor the ovary medially, and the suspensory ligament, which is going to anchor laterally, okay? In the suspensory you also have the ovarian artery and vein, which can also be called the gonadal artery and vein, okay? So here you can see the fimbriae really nicely, and then the fallopian tube coming over this way, going into the fundus of the uterus. You can see the nice big cervix here, the opening for the cervix, which is going to go into the vagina, okay? Now let's look over at this side where we've kind of cut it open so that you can see some of the structures a little better. You can see the ovarian ligament, and you can see how it's not an open tube. The fallopian tube is open, and when this right here drops into the pelvic cavity, this creates a current that sucks that oocyte up and brings it, if it's fertilized here, into the uterus. Now, one of the things that's interesting is that this current is really, really strong. So if I took out this fallopian tube for some reason, okay, this fallopian tube over here could actually suck that oocyte all the way from that side over into it, okay? So it's got a really good current for sucking up that oocyte. All right, let's go on to the last slide. All right, hysterectomies are cool, aren't they? No, they're not. There's actually really recent research that's come out this past year showing a connection between reduced cognition and the removal of the uterus. So it's starting to bring into doubt how frequently hysterectomies should be done. So like they should only really be done if they're really necessary. Now, this is the old way of doing the hysterectomy. This is basically the same type of a C-section cut where you cut through here. Unfortunately, when you do that, you completely sever the rectus abdominis. You're going to have a really intense recovery. And then they basically cut out the uterus and pop it out and then sew you back up. Nowadays, they much prefer to go intravaginally. And so they'll go in and they'll excise here and here, and then they'll pop it out. And you can do something that's really radical. You can also do a total where you take out all of the cervix and the uterus. This is what you would do if you were going to be doing a hysterectomy due to ovarian cancer. You would want, not ovarian cancer, cervical cancer, because you want to get the cervix out. If you're doing ovarian cancer, you're probably going to take out more. And then if you're just taking out part of the uterus due to damage or fibroids or something like that, then it's best to leave the cervix, because then they can suture it up so that it doesn't prolapse and fall out of the body, which happens especially in older women, to have a prolapsed uterus or cervix. Okay. All right. Anyway, so that was the end of part 1, and you can go on to part 2.